Hi everyone, welcome back to the video chapter 6.3. In this video, we are going to talk about chemical properties of benzene. By the end of the lesson, you should be able to explain the electrophilic aromatic substitutions reactions of benzene, illustrate the mechanisms for the following reactions, explain the reactions of alkyl benzene which include oxidations and halogenation. So for this benzene, its chemical properties depends on the structures. As you know about the structures of benzene, it has the formula C6H6. It is a very electron-rich species. So benzene will behave as a nucleophile. And therefore, it will react with electrophile. However, benzene ring is a very stable compound due to the completely conjugated carbon-carbon double bond, and this results in the stability of the aromatic ring. So the benzene will only undergo substitutions reactions. So the type of reactions is electrophilic aromatic substitutions, in which the substitutions occur directly at the benzene. So chemical properties of benzene basically classified into two categories. The first one is this electrophilic aromatic substitutions, which include nitrations, halogenation, Friedel-Crafts alkylations, and Friedel-Crafts acylations. Another reactions occur at this alkyl benzene. So reactions of alkyl benzenes means that the reactions occur at the alkyl substituents. And this includes the oxidations with hot acidified potassium permanganate or potassium dichromate. And also halogenations for these alkyl substituents, which is a revision for our chapter 5.1, the reactions of alkane, okay, free radical substitutions. So first look at electrophilic aromatic substitutions. So reactions occur directly on this benzene ring. So first of all, halogenations reactions. So the reagents and conditions when you have the halogens is either Cl2 or Br2 in the presence of Lewis acid, FeCl3 or FeBr3. So the functions of this Lewis acid, okay, it can use AlCl3, BeBr3 or FeCl3. So the function is to increase the polarity of our electrophile Br2 or Cl2. Thus, it makes this electrophile more electrophilic. So when these substitutions occur, one of the hydrogens in the benzene will be substituted with the halogens. So this is a halogenations reaction. Second reaction is nitrations. So the reagent conditions, we have the nitric acid and HNO3 in the presence of sulfuric acid, H2SO4, under the temperature 50 to 55 degrees Celsius. So one of the hydrogens will be substituted with NO2 nitro group. So substitute with nitro group is named as nitration. This NO2 is generated between the nitric acid and the sulfuric acid. So the formations will show you in the mechanism. Right, so next we have the reactions Friedel-Crafts alkylations. So pay attention to the spelling of Friedel-Crafts alkylations, including the dash and the S. So alkylations is referred to when we substitute one of the hydrogens which is directly on the benzene with an alkyl group. So the reagents and conditions include a haloalkane. RCl over here refers to a haloalkane in the presence of Lewis acid, okay, FALCl3. So for this alkyl group, you can do rearrangement, either is 1,2 hydride sheaf or 1,2 methanide sheaf in order to get a more stable carbocation. So rearrangement is possible for alkylation. Alright, so for one of the hydrogens is replaced with the alkyl groups from your haloalkane. So of course the side products will be HCl. Alright, so for the last reactions is Friedel-Crafts acylations. So acylations refer to when one of the hydrogens in your benzene is substituted with an acyl group. So this is the acyl group in which the alkyl group is attached directly to this C double bond O. Alright, so here is your acyl chloride. So imagine that we substitute the hydrogens, with these acyl groups, and then the remaining product, the side product, will be your HCl. Okay, so this is acylation. So in short, let's practice this mind map together. So for the electrophilic aromatic substitutions of benzene, so let's look at your halogenations. So when one of your hydrogens in your benzene is directly substituted by one of the halogens. So in this case, because reagents is Br2 in the presence of your Lewis acid, so one of the hydrogens substitute with bromine, and there's the side products of HBr. Okay, hydrogens from your benzene, Br from the Br2. The second reactions here, when benzenes react with the nitric acid, sulfuric acid under certain temperatures here. So one of the hydrogens is replaced with the nitro groups. All right, so you are forming your nitrobenzene. Okay, this is a bromobenzene, this is a nitrobenzenes. And there is a side product over here, which is your H2O. Alright, the next reaction is Friedel-Crafts acylation. So we have the haloalkane and in the presence of Lewis acid. So imagine one of the hydrogens. So if let's say I take one of the hydrogens from here and then it combined with the Cl to get the side product HCl. So where you break the bond, you'll connect to these halogens, in which will combine back at the bonding here. Okay, so one of the hydrogens is substituted with this alkyl group, so it's replaced with the bonding where the CCl bond is broken. Okay, so you got an isopropyl benzene. So again, keep in mind, I can substitute any of the hydrogens over here. So that means these structures can be rotated, and the carbon-sparing substituents will be your carbon number 1. So the last reactions over here, you have this acyl chloride in the presence of Lewis acid. So the hydrogens is being replaced with this acyl group. So imagine that hydrogens combined with this Cl. So you are breaking the bonds over here. So the side products, we have HCl. And then you are generating structures with this acyl substituents. So we have C double bond O connecting to a CH3. So the name of this product is what we call as the acetone phenol. Okay, acetone phenol. You can refer to the common name of a compound. Alright, so let's look at the reactions of the alkyl benzenes for the reactions that happen at the side change or the substituents. So first of all, oxidations of the alkyl substituents. So the reagents and conditions, we can use potassium permanganate, H+ in the presence of acid under hot condition. I can also use potassium dichromate to replace this potassium permanganate. Alright, so recall that the color of this potassium permanganate is purple color. For this potassium dichromate is orange in color. So for these oxidations of alkyl substituents, we must make sure the compounds contain benzylic hydrogens. So the benzylic hydrogens refers to when the hydrogens is attached to this carbon, which is directly attached to the benzene. So this is your benzylic hydrogens. This is your benzylic hydrogens, and this is your benzylic hydrogens. So it doesn't matter how many benzylic hydrogens are they, as long as you have at least one benzylic hydrogens, then oxidations will occur. So oxidations of alkyl benzene with benzylic hydrogens will produce benzoic acid, regardless of the number of carbon in your alkyl substituents. If there's only one carbon, so this carbon will be oxidized into benzoic acid. Okay, so from toluene into benzoic acid. As well as if you have propyl benzene, there's 3 carbons over here. So these structures will also oxidize into benzoic acid. Okay, the remaining carbons will produce as a carbon dioxide gas. Okay, so regardless of the number of carbon, as long as there is benzylic hydrogens, we are going to get the benzoic acid. If the alkyl benzene does not have any benzylic hydrogens, it is inert to oxidations. In other words, there will be no reactions for these oxidations. So as the carbon which is directly attached to the benzene does not have any benzylic hydrogen, so no reactions will occur. The reactions of alkyl benzene is halogenations of the alkyl substituents. So the type of reactions is free radical substitutions. As we have already encountered these reactions in the chapter 5.1, the reactions for alkene or cycloalkene. So now we are looking at this alkyl substituents group. So the number of products depends on how many non-equivalent hydrogens present in the structures. The reagents and conditions still the same. We have either chlorine or bromines under the presence of UV, heat, or sunlight. So in this example, you have a toluene. So at this case, you have CH3. One of the hydrogens is substituted with the bromines to produce this bromomethane, bromomethylbenzene, or another names benzyl bromide, and a side product HBr. For these halogenations, it occurs at the side change of our alkyl substituents. All right, let's try this as examples. So we are looking at the reactions of the alkyl benzene. So reactions happen at the side change. So for this species, we can name it as the isopropyl benzene. Or you may also write the structures in skeletal form. So isopropyl benzene. So first reactions here is the oxidations of our alkyl substituents. We're using KMnO4, H+, and in the presence of heat. So for these oxidations, please check your substituent. Is there any benzylic hydrogens present? We have our benzylic hydrogens here. So the products of these oxidations will form benzoic acid. Okay, regardless of how many carbons present. So the remaining carbons will form the carbon dioxide. And the second reactions here is the halogenations under the presence of UV, so free radical substitutions for these alkyl substituents. So for this CH3 and this CH3, they are equivalent. So you will substitute one of these hydrogens with the Br, and another products, we are going to substitute the center hydrogens here. So the first product, substitute the center hydrogens to get you a major product as the bromine attached to a tertiary carbon, which is more stable. And if we replace one of the hydrogens for either one of the CH3 groups, so you're going to form a minor product. So CH, CH2Br. Or maybe you substitute at the top, it becomes CH2Br at the top here. And don't forget your side product HBr. So remember brominations, we are going to label the major minor product. In the case if you're using Cl2, therefore you don't have to label the major product. It will be an equivalent amounts of mixture. So that's the end of our reactions. Remember 4 reactions for electrophilic aromatic substitutions and 2 reactions for the alkyl benzene.